Welcome to Synthesis Week 5. This week we're going to cover two very interesting topics, Raymond Scott and physical model. They're not directly related, but the experimentation that Raymond Scott did would begin the journey of synthesis into deeper and deeper sonic exploration. Raymond Scott was a 1931 graduate of Juilliard, and he went on to work in New York running a number of orchestras. In 1942, he was the musical director of CBS Radio. In 1946, he began the Manhattan Research Project in his basement way out on Long Island. He had the money to do it. He was like one of the original mad scientist characters. And he's responsible for a number of interesting innovations in electronic music. And some of these we're going to be looking at in more detail, including the circle machine and the electronium. So Branford Marsalis describes Raymond Scott as part of the DNA of 20th century music. He's built into a number of things that happened in 20th century music, including cartoon music. Warner Brothers purchased his whole experimental catalog and many of his regular type of compositions, and we see a lot of them in Warner Brothers cartoons today. So we're going to be looking more in depth in next week into Raymond Scott and some of his innovations and how he spans a large swath of American musical history. This week also we're going to be looking at physical modeling. Physical modeling is different than analog synthesis in that we now have a vibrating object. Whereas an oscillator was capable of producing fairly simple sine waves, square waves, and triangle waves, we now have an object which we can now algorithmically program to behave as if it were in nature. So what the synthesizer we're going to be going over this week is sculpture, apologic sculpture. And it is based on having an object, and this object is a string. And the string can be made of wood, steel, nylon, or glass. Of course, if it's made of wood, it starts to behave more like a block. So we can choose the material of this object, of this string, and we can also choose its excitation method. We can set it to motion with a bow. We can blow on it as if we're blowing on glass. We can do an impact strike or a gravity strike as if it's a piano hammer dropping on it. So we have all these different ways to excite the material. Not only can we choose the material, but we can also choose the excitation method. And this is where we are going to start on a really wonderful and very realistic journey. One of the things I love so much about physical modeling synthesis is that it sounds real. Why does it sound real? It sounds real because we've known the math for a long time. Since Fournier and Helmholtz, we've known about resonance, we've known about attack and decay, and we've known how items vibrate, and we can analyze them, and we can do Fournier analysis and break them down into individual sine waves. And so we've known all this, but we never had the computer horsepower to be able to generate sound objects in real time. So it's quite an amazing adventure that we're about to embark on. And there's also a technical lesson accompanying this week on exactly how to start getting into sculpture. And trust me, this is a journey, a marvelous journey, from which there is no return. There is only more sonic